In principle, identifying whether a value is a parameter or a statistic can be really easy or difficult. And actually, it's easy in the sense that it's probably going to be a statistic because we are rarely given information about the population because the populations that we deal with are typically so large that it's hard to get a grasp on what the parameter might be. Okay, so that's where we need to do inference, right? We want to know the value of the parameter, and to do that, we need to do some sort of inference idea. And we're going to call it statistical inference simply because we use a statistic to make an inference. Okay, so really the whole idea of statistical inference is we want to say something about the population, but how do we do it in a way that makes sense with a sample and is credible? Okay, and so yeah, there's a lot here. And you can see I color coded them because there's really two different questions in this one thing that we need to grapple with. And we're going to tackle that credibility piece first. Okay. When we talk about credibility of what we say, at least in terms of the inference, okay, we want to remember back to chapter 7. Okay. And everything that we do with a sample, we have to, I mean, if we're working with a sample, we need to make sure the sample is legit, right? And so back in chapter 7, we talked about those principles of experimental design, right? What were they? Okay, and this is where you pause the video, look back at your notes, and remember there's those 3 properties, okay? And so resume the video when you've refreshed your memory on what those 3 properties might be. Okay, so we really did pause the video. Okay, just making sure because the 3 principles are, remember, we want to control the effects of lurking variables, so that's where you do a control and treatment group. Principle 2 is you want to randomize whenever possible. Okay, random, random, random. And then principle 3 is you want to use a large enough sample, right? So have a sufficiently large sample size. Okay, and what that might mean in your context might vary, but those are the 3 principles, right? So those 3 principles are going to help us tackle this credibility question. If we collected the sample in a legit way that there's, we minimize bias to the best of our extent, that's going to go a long way. But beyond that, any statistics that we compute, we want to make sure that those are also unbiased. Okay, and you're like, how do you make mathematics unbiased? Well, that's where we need to make sure that any statistics that we calculate don't systematically differ too much from the value of the population parameter. Okay, or I should say over or underestimate the population parameter. Okay, and so if we have a measure that does not systematically underestimate or overestimate. And when I use systematically, that means we might have to do a lot of analysis, right, to make sure that it doesn't, go too far off from the population parameter. Then that measure is going to be an unbiased estimator. Okay, and that's a big theoretical concept in statistical theory that people have dedicated literally their whole lives to studying. Okay, so we're not going to dig too deep into it, but we just need to know, okay, what are the unbiased estimators we're going to work with? X bar. Okay, X bar is an unbiased estimator of mu, so that means you can use X bar in formulating an estimate for mu or making an inference on mu, your population mean. And actually, standard deviation is not that great. Sample standard deviation is actually biased. Okay, it actually systematically underestimates the population mean. Now I'm forgetting. It is underestimates because you have to add something back in. However, it is found that sample variance is actually an unbiased estimator of the population variance. Okay, so just remember when we square the standard deviation, we get the variance. Okay, so yeah, so we can use sample variance s squared as an unbiased estimator of sigma squared. Okay, now the big question is, why do we care? Well, we want to make sure, again, we don't introduce any bias in that we're saying something that is credible. Okay? It would be unfortunate if we gathered a good sample, right? Simple random sample is kind of our goal, and we do all this good sampling stuff, and then we mess up the calculations, right? So let's not mess up the calculations. Okay, so we've talked about that credibility piece, right? We want to make sure we get a good sample and we want to use unbiased estimators whenever possible. Okay, the next question is how? How do we make an inference with a sample? Okay, and that's where we're going to explore in, or that's what we're going to explore in the next video.